Hi everyone, we are now doing lecture 7. As all we know, number of people who have coronavirus is not decreasing. They are decreasing, but that's not enough to start our ordinary life. So that the university uh, ask us keep having those kind of online class again. So we are doing online class. Actually, the reason why there are already something that I wrote is because actually there was something I recorded before this lecture. Actually, it was gone. Unfortunately, so that I'm recording this lecture again, so that there's something I wrote here. Okay. So what we are doing, what we have learned so far is about several solution concepts. First one is IESDS, and the other one was Nash equilibrium. And another one was SPE, or subgame perfect Nash equilibrium. Okay. When we are looking for just an equilibrium based on IESDS, actually, in some sense, this equilibrium is very strong because to find that equilibrium, what we need, what we assume on humans, that was just people's rationality. We don't need more than that. But when we try to find a Nash equilibrium, we need a belief that others will stick to Nash equilibrium. In order to do that, we usually will assume that people will people will use some experiences, information, or data on something. Likewise, when we try to find a Nash equilibrium, basically we are using more information than IESDS. In other sense, I mean, IESDS's equilibrium is stronger than Nash equilibrium. Also, we came up with a new solution concept called the subgame perfect Nash equilibrium, in short SPE. This SPE is very similar to Nash equilibrium, but one big difference from Nash equilibrium. This SPE is finding an equilibrium with considering order information. So here, when we are looking for in this SPE, there are different orders of timing of the players. So from now, what we're going to do, we will see several applications with using this SPE or maybe extensive form game. The first one is about stackable game. Another one is bargaining game that is very famous and very useful. After finishing those kind of applications, one or two more, then we will move to your personal project. I ask you to make or develop your own idea. The topic is okay in any sense, but you should use game theory tool to develop your idea. That was only one requirement of your project. But you don't need to make a very strong model. Just I ask you to just to use some flavor of game theory. That's enough. Okay. So anyway, what I'm going to do today is to do a stackable game. This is very similar to Chrono game. Okay. Um, so there are several versions of the stackable game, but this one is a very simplified version of a stackable game. So here are two players, two actually firms in a market. You can come up with any market. In this market, demand curve is like that. Market price equals to 100 minus Q. So this Q refers to the market quantity. and P is the market price. Here are two players, leader and followers. No follower form. What they are going to do here in this market, they will decide the amount of production. Because they are producing identical goods, there is no difference about the quality of the good. Okay, the goods are basically the same for the consumers. So what they can choose in their perspective is the amount of production. I mean, leader company's production is called QL. Follower company's production is called QF. That's it. Well, because this is a game, probably there will be, we can find this three main sets. For example, who are the players, leader and follower. In short, I'm going to take just the capital L and capital F to refer to these leader and follower companies. And leader will decide the amount of the quantity QL. The follower will decide the amount of the quantity QF. And also we can come up with strategy set. Strategy set, for example, for the leader is any non-negative number. Because this is about the quantity or production, it should be non-negative number. Here is also followers strategy set. The followers strategy set will be any non-negative number because this is again about a production. To set up this market situation, we assume that marginal cost is 10, fixed cost goes to 0 to simplify the model. And here, market quantity Q equals to the sum of the QL and QF. Because here are just two firms and they are producing goods, and the total amount of goods they produce will be the market quantity. Okay? If we stop here, then this is exactly the same as the Kruno model. Because here are two firms, even though I'm naming differently, but what they are doing here is the same because they are choosing the production, amount of production, and the follower is also choosing the amount of production. So those are the same. And also here are market situation, and also we can calculate outcome payers. For example, leaders profit or payoff is total revenue minus total cost. This is the money you can earn when you are producing certain amount of good. This is the cost to produce a certain amount of good. So that is the profit. And total revenue will be price times the quantity. Because here, the reason why I put here QL, because this QL is the profit of the leader company. So if the leader company says QL amount of good with price P, this is total revenue. And also we can come up with a total cost. Total cost is, if this company produces QL amount of good, then to do that, they need a marginal cost of 10, but no fixed cost. So that is total cost. So that is the profit. And because we assume that every company will maximize its profit, we assume that. So they try to maximize this thing by adjusting, their production. And also, follower company will, decide how much they will produce. Everything is the same as a Kruno game. So far, if we stop here, this model is basically the same as the Kruno game. But here is just only one difference. That is that the timing. If we come up with the Kruno game, in the Kruno game, players will decide their action simultaneously. When I say simultaneously, basically it refers to the case when companies will choose their action at the same time. Or even though they choose their action in a different time, if we don't know what another company is choosing, then we call it that situation also a simultaneous game situation. So that was about chrono game, but here, timing is different. Leader will decide their production first, and then the follower will decide its production after observing the leader's production. So the timings are different. The leader will choose first, and then the follower will choose. So here are time difference. In a chrono game, there is no time difference. They will choose simultaneously or at the same time. But here they are different. And also follower will observe what the first company will choose. And then the follower will decide. So timings is different. Maybe why should we make those kind of model? That is very fundamental question. Why? Because we need to illustrate a situation where there is a leader company and there are followers or following companies as well. We can come up with those kind of examples a lot. For example, if you think about a semiconductor industry, if you come up with the semiconductor industry, maybe you can come up with Intel, Samsung, Hynix, Toshiba, and so on. Maybe Micron, and so on and so on. This is a kind of, even in a semiconductor industry, this is about memory semiconductor industry, I think. Anyway, if you think about that industry, you can come up with main players which has more power than other companies. Usually their sales, the amount of sales is bigger than other companies, and also they have more ability to develop better product than other companies. In that case, usually there are leading companies which try to decide first, and also there are following companies which try to decide after observing what the leading companies are doing. Okay? So it's like there are different levels, even though they are competing in a market. This is not the only market. You can come up with very, very many markets where there are different level of companies. And leading companies are deciding first, and the following companies, after observing the leading company's behavior, they will decide. Not even in a market. If you think about universities or colleges, even in universities or colleges, there are different level of universities and colleges. It's like there are leading universities and following universities. Leading universities will have more students, more money, budget, and they can produce high quality of research than other company or other universities. And compared to those kind of leading universities, also there are following universities. They observe what the leading companies were doing, and they report to that leading company, then decide what they are going to do. So not even in a market, you can find many examples which can be applied or which can be understood as this Stark-Helberg model. That's why we are learning this Stark-Helberg model, okay? I'm stopping there. I'm dispersing. Okay, I'm back. So also we can illustrate this game with a tree. So once the game is started, the leading company will decide how much it will produce between 0 to infinite. It can choose any number, and usually it will choose any non-negative number QL. There are many infinitive number of branches between these two branches, actually. Anyway, if QL is decided, then the following company will observe that. Following form, observing that. At every node here, there is the same branch of nodes here. But anyway, QL is decided, then following form will decide QF from 0 to infinity, right? So there are infinity number of branches here. At this node, the following company also will decide from 0 to infinity everywhere. So you can draw this kind of branch in your mind. So well, as you can see, the leading company first decide the QF, and then following company is deciding QF. So if this node is reached, then again, leading company's output is that 100 minus Q times QL minus 10 QL. So if I simplify their payups, that is 90 minus Q times QL. Likewise, also we can calculate following companies' payup. That is the same, 90 minus Q minus QF. That is the payups at every terminal nodes. There are infinite number of terminal nodes. I mean, in any terminal nodes, once one node is reached, their payups will be like that. Okay? How can we solve that? Now if we start here, how can we solve that? Basically, this is an extensive form game. When we try to find an extensive form game, we can find SPE. Also, we can find the Nash equilibrium here. However, if we find a Nash equilibrium, I mean, we are not sure whether it is credible, because Nash equilibrium is not credible in some cases because it is not reflecting some information on others. But right, so we need that. But anyway, because this is an extensive form game, we are going to use SPE, or subgame perfecting Nash equilibrium. And how can we find the subgame perfecting Nash equilibrium? One way is to use just definition. We are finding every kind of Nash equilibrium in every subgame. Then we are finding an equilibrium in common in every subgame. That is a subgame perfecting Nash equilibrium. However, that is too complicated, so that it takes too much of time. Usually, we are using backward induction. What it means, we are going to reason from the end. At every node, we are going to find the Nash equilibrium in every last subgame. So you can come up with in this subgame. In this subgame, once this node is realized, already leader choose QL. Then here, following company will choose QF. So it's like this is the way that this QL is given. So this is the way, because we are thinking from the backward, it's like this subgame is already realized. Then we think the last node QL is realized, or QL is given. So this is much simpler way to find SPE. It's like we think that QL is given. And now QF, the following company will choose QF. Okay? Now let's think about how it works. Because we are going to think from the last node from the end, follower will maximize its profit with the given QL. So follower thinks that the given QL, the leader's production QL is given, or maybe the leader already chose QL. If so, follower will maximize its profit. 90 minus Q times QF. Again, Q is just a sum of QF and QL. By definition. And previously, follower didn't know which production is realized. But however, here, when we try to solve this with a parallel induction, the follower thinks that this QL is given. It's like it is constant, not a variable. Then we can solve this. This is follower's profit by taking a derivative then here's the minus sign, only minus sign is remained, QF, by applying chain rule. So this whole thing is survived. So what it means, the follower will, if we simplify this, 2QF minus QF minus QF by moving those two terms to the right hand side, 90 minus QL, this, okay? Then QF is 45 minus a half and QL. What it means, this is a kind of the best response function. Right? So what it means, okay, if the leader decides QL, then follower company will decide its production as much as that ton, okay? Follower will choose that one, okay? Now, let's think about the leader's perspective. From the leader's perspective, leader haven't decided which production it will produce from 0 to infinity, QL. But the leader knows that if the leader decides QL as a strategy, then leader knows that, then follower will choose QF star. Why is a QF star 45 minus a half QL? So what it means from the leader's perspective, if I'm choosing QL, then follower will choose 40 minus a half QL, right? So now going back to the leader's profit. Leader's profit looks like this: 90 minus QF minus QL times QL. Previously, when the leader tries to decide its production, it didn't know what number will be for QF. But now the leader knows that number. So I can substitute this QF as this one, minus 45 a half QL times QL times QL. If this terms in the parenthesis is simplified as 45 plus a half QL minus QL, so a half QL times QS. Now the leader is maximizing that term. So I'm going to erase that area. So leader now is maximizing its production QL, and the leader's profit, that is 45 minus a half QL times QL. So we can take a derivative about this term. So partial Q profit, partial QL is here minus a half remains QL plus 45 minus a half QL, because this is things equals 0. So we are looking for that number what satisfies this equality. Then QL star, this is just QL is 45. Then from here, because the leader will decide to produce 45, then follower will decide 45 minus a half QL. This is 45, so that this is 22.5 units. This is the production level of the leader and follower. And what's the market price? Market price is 100 minus Q, 45 plus 22.5. So that is 55 minus 22.5. 5, 4, so 2, 32.5. That is the market price. And based on that, we can calculate the overall profit, right, for each leading company and following company. If I'm calculating leading company's profit, then that is leading company's profit. This is 22, 45, 22.5 times 45. That is the profit for the leading companies. And for the following companies, this is profit for following company. 90 minus 45 minus 22.5 times 22.5. If you calculate that, that's 22.5 square. Surely that number is smaller than that number. So that is the basic, the production level, okay? But you know, there's one thing to be careful when we are looking for subgame perfect Nash equilibrium formally. Then so we are looking for subgame perfect Nash equilibrium. Subgame perfect Nash equilibrium is one strategy profile which consists of each player's strategy. So let's look at what is the SPE for the leading company. Leading company's SPE is to produce 45. What is SPE for the following company? Is it 22.5? No, that's wrong. Because what is the strategy? Strategy is the contingency complete plan for every contingency. Look at this. How many contingencies the following company has? The leading company has just one contingency, one information set. However, the following companies, there are infinity number of contingency, or maybe infinity number of information set for the following company. So when the leading company is to produce 22.5 units, this is not what the leading company is that, what the SPE for the following company, it should express what kind of strategy you do produce at every contingency. How can we write that? We should write this. QF is 45 minus a half QL. If we write in this way, for example, when this node is reached, when QL equals to 0, then in this subgame, the following company will produce 45. For example, if the leading company produces, for example, 100, and if you put here 100, it's 50, there's a minus, but we don't have a minus. It doesn't make sense. So, following company's equilibrium strategy will be this. It should be non-negative number. This is actually, those two is the SPE, subgame perfect Nash equilibrium for the following company. Because, for example, when QL equals to 100, there's minus 5, but it can be minus number. In that case, it should be 0, so 0, if we take this. So those two is the subgame perfect Nash equilibrium. And this 22.5 is outcome. Because these two players are choosing these strategies, so the following companies will reach it to that outcome, 22.5. Okay? So that is the result. This is subgame perfect Nash equilibrium. Okay? What is the meaning of this Stackelberg game? If you look at this, those two companies, there is no difference for the technology of production because the marginal cost is just 10, which is the same for those two companies, and the fixed cost is 0. Usually, cost structure is reflecting this company's technological level of the company. So in that sense, these two companies' technological performance are the same. However, only difference for those two companies that leading company is deciding first, and then following company just following after observing the leading company's behavior. That is the only difference. I'm not sure whether you remind Chrono Games result, but we can compare this result with the Chrono Games result. I'm going to do that. To erase, I'm parsing. Okay, I'm back. Now I'm comparing this result to the result of a Chrono Game. Everything is the same. Only difference is that the Chrono Game, they choose their production level simultaneously. That's only difference. So in the Chrono Game, again, there are two players, leader and followers, or maybe I can call it first player and second player because there is no difference of timing of choosing. But anyway, I'm using the same notation. And again, their strategy set is a non-negative number, like non-negative number. Same. And also the profit leader, we already did this, so I'm not going to show how I derive this. And followers profit is 90 minus Q times QF. So this make a normal form game without considering timing. When we did this in a StarCalibur game, the leader first decides and then the follower observes that, then decide its production level. However, if we do this in a Chrono setting, because they choose their actions simultaneously, so timings are different, and then they will do this. Because there is no timings, when they are choosing their behavior, they will expect that others production level QF in this case others production level QL is given. What it means, that number they regard as a constant number. I don't know what that number is, but that number is given so that number is not changing. That's what they are expecting. So let's think about from the follower's perspective. Even though I call this form follower, but there is no timing difference between those two companies in a Chrono setting. So again, maximize profit 90, because Q is all the time QF, QL. By taking derivative, we already did this before, QF. Again, here's minus QF minus 90 minus QF 9 minus QL equals 0. The reason why I'm calculating like that is because the following company assumes that this QL is given or constant. So from here, again, QF star is 45 minus a half QL. What it means, I don't know what the leading company is going to choose. but I'm taking the leader's production level as given, and then based on that, I'm going to choose my best response. But now look at the leading company, leader. I mean, from leader's perspective, the things are the same. Nothing is changing, nothing differs between the following companies. In the Kronos setting again, what they are doing, they are maximizing QL 90 minus Q times Q leader 90 because QL is consisting of QF QL times QL. This is the profit. The leader is maximizing this. So taking derivative here minus QL minus plus 90 QF QL equals 0. If I'm summarizing this, QL star is 45 minus a half QF. What it means, because they are choosing their production level simultaneously, so that they don't know what other company is choosing. What can they do is to expect that other company is choosing that. Given that production level, they will decide if once the other is giving us that production level, this company will decide how much they will respond to that. Then, how can we find an equilibrium? Well, we can find an equilibrium by solving these two equations simultaneously. Because the QL star is 45 minus a half QF, QF is equals to this 45 minus a half QL. Then we can solve with this now. It's 22.5 and plus QL. If we reorganizing, this is 3 over 4 QL, 22.5, then QL, 22.5 times 3, 4. Well, we can do that. 21, 7.5, then that is 30. And if we put 30 here, that is 50, then QF is also 30. So, equilibrium quantity in a Kronos game, QF, QL equals to 30. The market price is 40. And also we can calculate the one company's profit. For example, leading company's profit, because they are selling 30 units with price 40 minus marginal cost is 900. Look at this. I need to calculate this 45 times 22.5. Just to simplify number 15, 13, 90, 5 is 3. So what we can see is that this number is much bigger than that number. So what is the meaning? In the same setting, if we assume that two companies are deciding their production level simultaneously, they will choose 30 units, right? But with the same cost level, or maybe same production performance, if one company decides first and then the second company follower decides, then we can see that because of just timing, the leading company can take more profit and can produce more than the Kronos game. That's quite interesting. Why this is happening? Because the first company can choose first. So, the fact that one company can choose first gives us give that company an advantage of, initiating the market. So, the right to move first itself is a kind of way of initiating the market. We can see that by comparing the result of Chrono game and the result of the Stack Hammer game. This game is a quite simple version of the Chrono and Stack Hammer game. However, maybe you can make a very interesting example example that you want to look at in a real one, and you can make a model based on by using those kind of Chrono and stackable game. That's quite interesting. Okay, so the first half lecture is done here.